Vamorolone is a steroidal anti-inflammatory, but it's not a member of the corticosteroid class. It still binds the glucocorticoid receptor, which mediates the anti-inflammatory efficacy of the corticosteroid class, like prednisone, dexamethasone, deflazacort, et cetera, all that large class of steroidal anti-inflammatories. So while binding the receptor, it loses one interaction with the receptor, so it's chemically different, and it turns a bit and it changes the downstream structure-activity relationships. And there's two ways it does that. What we know from a lot of research now in terms of anti-inflammatory efficacy is that's mediated through innate immunity, NF-kappa B signals, where the steroid drug, the receptor drug complex blocks NF-kappa B signaling. So it actually sits on the DNA and genes that are involved in NF-kappa B and innate immunity and blocks them from being activated. So that's the anti-inflammatory mechanism of action of the corticosteroid class. Vamorolone is a drug that will tweak it binds the receptor and still does the anti-inflammatory activity. So we've kept that intact. But there's a separate activity of the corticosteroid class, which is called transactivation, which is actually the ones that most people have studied in medical school or graduate school, where it turns on genes. It turns on an enormous number of genes. So remember, in innate immunity, you're blocking it. With transactivation, you're turning it on. And a whole chunk of your genome is activated by corticosteroids and the glucocorticoid receptor. That seems to be linked to more side effects. So what vamorolone does is not turn on those genes, or much less. So we've lost that transactivation, the turning on of genes, but retained the transrepression or shutting off of NF-kappa B, and that becomes then a dissociative steroidal anti-inflammatory. We sort of separated out the efficacy from the side effects. And so so far that's what we've seen clinically and also preclinically. Preclinically in a large number of anti-inflammatory disorders, well, about 6 or 7 or 8, including asthma and arthritis and muscular dystrophy and multiple sclerosis. Clinically, we've just taken it forward so far in Duchenne muscular dystrophy as its first indication. And there we see strong evidence in a double-blind placebo-controlled study of improvements in motor outcomes. So whereas Duchenne kids without corticosteroids or vamorolone are stable or decline at a young age range, with vamorolone, they show strong improvement. And both a 2.0 and 6.0 mg per kg per day dose seem effective. And so far they seem safe. We're not seeing any of the growth stunting even over 2.5 years. And many more safety outcomes are studied, and both long-term and biomarker short-term, and we're still analyzing that.